This video will talk through basic function notation. So we've already been working with XY ordered pairs, and we're now going to take this and turn it into a linear function using function notation. And what I'm going to do, I'm going to replace the y with a lowercase f and then an x encased in parentheses. And the way that I would say this is actually said f of x. So that notation represents f of x. And really what it is, y is being replaced by f of x, meaning that this equation is a function of x. So when I look at the equation, the variable that's going to appear in the equation is going to be x. I could rewrite this given equation in this manner. I could say that f of x equals 2x minus 8. That's exactly the same thing as stating y equals 2x minus 8. So the notation f of x and the variable y are interchangeable. They mean exactly the same thing. So I would say f of x equaling 2x minus 8. That would be taking the equation written in the xy notation with the xy variables and replacing it with function notation, meaning exactly the same thing. So now my ordered pair, instead of being xy, I can think of my ordered pair as x f of x. I start with my domain, my input x values. I run those x values through a certain function with the variable x in it, and then what would come out would be the associated y values. I'm doing exactly the same thing, but it's just a notation method. So let's look at some of the problems to see how simple this is to use. The notation replaces a lot of words. So here I'm going to be evaluating functions, and they're using the function notation. So instead of writing y equals x plus 7, they're giving me the notation f of x equals x plus 7. So that means that when I look at my equation, the variable in the equation is going to be x. Now the notation that follows, this is telling me f of 5, that's my cue that everywhere I see the variable x in my function, I'm going to let that value become 5. So this is telling me that I'm now going to have 5 plus 7. So my associated outcome would be 12. In the next example, I'm going to have negative 1 plus 7, so my output would be positive 6. Negative 3, that means x is negative 3. So if I were to pick ordered pairs out of this, which I think is an important thing to understand, my x value is 5, my y value is 12. So the ordered pair associated with that would be 5, 12. Here my x value is negative 1, my y value is 6. So negative 1, positive 6 would be the xy ordered pair associated with that. And then lastly, I would have negative 3 and positive 4 being the ordered pair associated with that. And this is all about notation. The notation is replacing a lot of words. Another way to state this, I could say that f of 5 equals 12. I could say that f of negative 1 equals 6, and f of negative 3 equaling 4. So the ability to understand how to use the notation, that's an important skill. The ability to take the notation and write an ordered pair that you would be able to plot on a graph, that's an important skill. And the ability to know that this notation is implying the ordered pairs, that is also an important skill to take away from this. Let's do one more on the video before I end it. Let's look at something like number 6. And the reason I choose this is because of the squaring. So my function is f of x equaling negative x squared plus 6x minus 4. So let's focus on f of negative 3. So this is telling me that x equals negative 3. The negative sign is built into the function, and the value of x is negative 3. So that means that I'm going to be squaring the negative sign with the 3. And I'll write the original function in blue, and then I'll put the suggested x value in. I'll use that. I'll put that in red. So I've taken my function that I'm given, I've taken this function, and I'm now evaluating this function for x equaling -3. That's what this notation is telling me to do. And I'm choosing this as an example because of the negative signs. When you're given a negative x value to substitute into an equation that's squared, it's implied that you need to square that negative sign as well. But this problem has a negative sign built into it, so the blue negative sign is going to stay in the problem. When I square the -3 times itself, that becomes +9. And then moving on across, I have +6 times -3, so that's going to become -18, and then nothing happened to -4. It stayed exactly the same. So here, -9 and -18 is -27, and when I add in -4, that gives me -31. So the value of this function at -3 is -31. So let's kind of wrap this up and make it a little bit simpler. The ordered pair associated with this outcome, if I had to plot this on a graph, this would be -3, -31, that would be my ordered pair. This is the ordered pair represented in function notation. The way that I arrived at -31 is by taking this -3 and plugging it in for x everywhere x occurs in this particular function. So this is not linear. This is not a line. If I were to graph this, this would be a curve. This would not be a line. But it's an important skill for you to be able to evaluate negative numbers into functions when a variable has been squared. And that's why I choose to do this on the video. Let's look at one more thing before I end this video. And let's look at number 12 together. So number 12, I have a curve that's already graphed for me, and I'm asked to identify, it says given the graph of function f of x, find each of the following. So this notation is suggesting that x is -4. I'm supposed to find the y value that coordinates with -4. So when I look at my graph, x is -4, there's -4. I scoot up and I pick up the y value that's associated with x being -4, and I see that y would be +2. So the point on the curve would be the point -4, +2. And the notation is powerful because it's telling you what to do. If x is 0, which y value is associated with x being 0? So when I look at the curve, here I am at the origin. So that's just simply going to be the origin, the point 0, 0. So when x is 0, y is also 0. So to look at b in function notation, f of 0 is 0, and then to look at a in the function notation, f of -4 would be 2.